Hey guys, I want to go ahead and give you some more examples on particle motion, and that's what we've been working on. This question is from 2016, so just kind of the purpose is just to make sure you're able to understand what is being asked of you, the question, and just being able to attack it. Because if you know what they're asking you and what to look for, then that's half the battle right there. So in 2016, they had this question. It said for time greater than zero, particle moves along the x-axis. The velocity of the particle at time t is given by this equation here. The particle is at position x equals 2 and at time t equals 4. Now actually this is a little misleading. So how would you write this, right? Because this is the position. Now you see how it says x equals 2? That's kind of misleading. Because remember, your x is always the independent variable time. So actually you should write it like this: x of 4 is equal to 2. Okay, or s of 2 if you want to use the s variable. Okay, but your time is your independent variable. Don't get fooled by this x. Okay, so remember, part A is the easiest part of all. Okay, that should take you about 2 minutes. Okay, so at time t equals 4, the particle is the particle speeding up or slowing down? Now remember, we talked about this the other day, speeding up or slowing down. There's two things you got to look at here. We got to look at velocity, okay, and we got to look at acceleration, all right? So at time t equals 4, so I got to look at velocity when time equals 4, and I got to look at acceleration at 4, okay? Remember, if the signs are the same, it's speeding up. If the signs are opposite, then the particle is slowing down at that particular point in time. Okay, so what's v of 4? You're going to plug it in here. Okay, and this is a calculator question, of course, because you have the sign here. So when you do that, you should get 2.978 if you truncate it to 3 decimal places. And then your acceleration, that means you're going to get the derivative v prime of 4. So you would just take your calculator, plug in the derivative, and you would get negative 1.164. Okay? And what do you notice? You notice that the signs are what? They're opposite, they're different. So what happens? At time t equals 4, the particle is slowing down. Why? Because velocity and acceleration have different signs or opposite signs, however you want to say that. Okay, and that's it. That's it. You're done with that. But notice how I used the same question to answer it. Okay, at time t equals 4, the particle is slowing down because velocity and acceleration are different. Okay, or have different signs, and that's it. Okay. And that gives you 2 points there with the conclusion with the reason. Part B, find all times t when the particle changes direction. Okay, changes direction. Now remember, we looked at the example of driving a car. Okay, imagine yourself driving a car. How are you going to change direction, right? You're going to come. If you want to make a U-turn, you got to stop, right? Slow down to a stop, and then what? Turn back around. So that's what you're doing, okay? You're driving and you come to a stop. So what do you have to do? You have to find v of t when it equals 0. That's what you have to do. So you're going to set it equal to 0. And so you're going to set this guy equal to 0. And you're going to find your critical points where it crosses the x-axis here, okay? The other thing you can do is you can graph it and see where it crosses the x-axis. And when you do, you should get t is equal to 2.707. But it's important, and if you saw the video from yesterday, and I know we talked about it, when you're doing these problems, you notice that the same type of questions are coming up again. Speeding up, slowing down, changing direction. Okay, so that's something to look for. Okay, something to expect, because these things, they're not trying to trick you. They're just straightforward. And so So when you're doing this, just go over it in your head again, and practice using your calculator effectively. So now that we have this, okay, we're going to put 2.707 here. Where am I going to plug it into? You're going to plug it into your velocity. Where is velocity? Because remember, velocity is a vector. If it becomes negative, then it goes to the left. If it's positive, then it's going to the right. Okay, so if you pick a value that's less than 2.07, let's say 0, all right, to the left, you should get positive. Okay, and if I pick 0 here, 0 squared is 0, divided by 2 is 0, sine of 0 is 0, and then 1 plus 0 is 1. And then something here after 2 is going to become negative. So when is the particle changing directions? Right here. Okay, right here. You can say the particle changes direction at 2.07 because, okay, because the sign changes from positive to negative, okay, or because velocity changes from positive to negative, and that's it, and that's your justification. And always try to go back to this part right here to use your justification. Okay, so that was pretty easy. We got those two problems. That's 4 points. Part C, find the position of the particle at time t equals 0. Okay, position. Well, what do they give me? They give me velocity. So how do I find position? You're going to take the integral of velocity. Okay? You're going to take the integral of velocity. Now, where do I start? They tell me this is my initial condition. So we're starting at where? We're starting at t equals 4. And they want to know the position at what? 0. So from 4 to 0. Okay. And then what happens? Well, if you do your antiderivative, you're going to get x of 0 minus x of 4, the fundamental theorem. And now I have to find what? The position at 0. So I'm going to take this guy here to the left. Okay. And hopefully it doesn't confuse you. But so we're going to have x of 0 equals this guy comes over here, becomes a positive, plus that integral. The integral from 4 to 0 of vt dt. Okay? You got to show that integral, okay? You got to show that integral because that's fundamental to the question. All right? Now, of course, this is a calculator problem, and this is probably all you would do. But x of 0 is equal, what's our initial condition? X of 4 is equal to 2. Okay? You can use s if you like to. If you plug this into your calculator, the integral, you're going to get a negative. And that's okay because, of course, the limits of integration are switched. So negative 5.8150027, and then your answer ends up being negative 3.815. Okay, so the position of this particle at time t equals 0 is over here. It's to the left. Okay, A, B, and C. So now part D. Okay, part D. It says find the total distance. You see that? We talked about that yesterday as well. Total distance. What's the total distance? It's the absolute value of velocity. Remember that. The absolute value of velocity. Okay. What's the total distance of the particle from t equals 0 to t equals 3? So we're going from 0 to 3. And there it is. Okay, guys. So now I have to just do this antiderivative. And of course, put it in my calculator. And you should end up with 5.301. Okay, and that's the total distance traveled. And you could just say the total distance the particle travels is 5.301. Okay, and that's it. But most importantly, when they say justify your answer, that's when you really have to give the explanation. So for this one here, find the total distance, you can just give this, you'll be perfectly fine. So that was from 2016. Let's go ahead and do 2017. Okay. And this was question 5, and this was a no calculator question, which is good because it helps us practice our calculus. All right, and I want you guys to take a look, okay, how the question is written. All right, so just so you guys can just be prepared. In previous years, they usually just gave you one equation for the particle and talked about that, or maybe another one. But this one now, notice how it's written. Now it says two particles move along the x-axis between 0 and 8. The position of particle P at time t is given by this guy. Okay, it looks kind of intimidating, right? With x of P of t. So this is the position of particle P at time t. Well, the velocity of particle Q is given by this guy. Okay, this quadratic. Particle Q is at position x equals 5 at times t equals 0. So this guy, be careful again, okay? X of 0 is equal to 5. All right? Remember, time is your independent variable. So part A is the easy part, or should be the easy part, right? It says for 0 to 8, when is the particle moving left? Now remember, velocity is a vector, okay? Velocity is a vector. So when is it moving left? Well, when velocity is negative. So what you have to do for part A, take your velocity, set it equal to 0, okay? This is kind of like a max or minimum problem, right? So you take your velocity, okay, set it equal to 0, and you find your critical points, okay? Of what particle, what? P. So you got to find the derivative of this guy, okay? So, and I'll just put V of particle P right there. So what's my derivative there? Okay. We'll do it the long way. Ln, that means it's going to be 1 over t squared minus 2t plus 10. Whoops. Times, remember, okay, chain rule. Okay, what's on the inside is t squared minus 2t. What's the derivative of that guy? It's going to be 2t minus 2. So you're going to end up with 2, I'm going to factor it, times t minus 1. And then you're going to have t squared minus 2t plus 10. You're going to set this guy equal to 0 because you want to find the critical points, where it stops, where it changes direction. Okay, remember, you're driving the car. Okay, you're driving the car, you slow down, you stop. All right, you stop because you're going to change direction. And you want to know when you're moving left or right. So you set it equal to 0, and when you cross multiply here, okay, this becomes a 0. So you're just left with 2 times t minus 1. Well, when you divide by 2, okay, you divide by 2, you're left with t minus 1 is equal to 0. So your critical point is at t equals 1. So at t equals 1, that's your critical point. Okay, so where are you going to plug it in? You're going to plug it into your velocity. So your velocity for particle P. All right. So, okay, where's my velocity? It's this guy right here. Okay, so you plug in 0. All right, and you want to figure out, is it positive or is it negative? All right, so you plug in 0 here, minus 0 here, that gives you 10. Okay, you plug in 0 here, that gives you negative 1. Negative 1 times 2, that's a negative. Cool. What about if I pick a number greater than 1? Let's pick 2. 2 squared is 4, minus 2 times 2 is 4. So that becomes 4 minus 4 is 0 plus 10 is 10. So the bottom is 10. That's a positive. What about the top? 2 minus 1 is 1. That's a positive. So positive divided by a positive is a positive. So when is the particle moving left? When it's less than 1. Okay. So the way you're going to write this, you're going to tell them when is the particle moving left? You can restate this. For the time between 0 and 8, the particle P is moving left when? Here, when t is less than 1. Okay, or actually, if you want to be more specific, between 0, okay, and 1. Okay, but if you just include this, if you include for the time between 0 and 8, the particle is moving left, t is less than 1. And that way you already include the 0. All right, guys. Now that one took a little bit longer. I'm surprised, but it's okay. And with that one, you would get 2 points. But hopefully it's making sense. You're understanding what they're asking, what they're looking for. Okay. So part B. So for the time between 0 and 8, find all the times t during which the two particles travel in the same direction. Travel. Well, wait a minute. When things travel, what are they talking about? We're talking about velocity. They're moving, aren't they? Okay. So we got to find out when they're traveling in the same direction. Okay. So I need my velocity of the p particle, and I need the velocity of the q particle. Okay, now in part A, I already did this. Okay, now I need my velocity for particle q. All right, so hey, check it out. They already give it to me. Nice. So the velocity of particle q is t squared minus at plus 15. And you notice that when they're asking you to do it by hand, they're not asking you to do this complicated algebraic manipulation, right? It's straightforward to the point. You should all be able to factor this guy, and you should get t minus 3, t minus 5. All right? Great. So when we set this guy equal to 0, okay, well, why do we have to set it equal to 0? Because remember, we need to find those critical points to see when they're changing direction, and when it's positive, when it's negative. So now t equals 3, and t is equal to positive 5. Okay, so now we're going to go ahead and do our number line. So remember, this left is the smaller value, and then on the right you have the bigger value. So here, now we need the velocity of our q particle. All right, so then pick a value that's less than 3. Well, pick 0. 0 minus 0 plus 15, that's positive. And what's a number between 3 and 5? We pick 4. 4 squared is 16, okay? Times 2, actually I'm going to do 16 plus 15, that's 31. And then 8 times 4 is 32, so 31 minus 32, that would be a negative, okay? And if that confused you, just go back and pause the video, plug in 4. A number bigger than 5, well, let's pick 6. 6 squared is 36. 36 plus 15 is 51, okay? 51, take away 8 times 6. 8 times 6 is 48. 51 minus 48, that's a positive. Okay, there it is. So it's moving to the right, it's moving to the left, it's moving to the right. So when are these two going in the same direction? Well, if that confuses you, let's go ahead and do our other number line here. Okay, so v of p, okay, where is 1? 1 would be over here. Okay, and then we said over here it's negative. Okay, and after 1 it's positive. Okay, so where are they have the same direction, the same sign? Okay, and if you notice, okay, it's gonna be, see, here's negative, this is positive, positive. Okay, these are all positive, positive, all these are negative, positive, 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 and all these are positive, 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 positive. Where do they overlap? So you see here, so between 1 and 3, and then between 5 and infinity, no, 8. Remember, because it only says from 0 to 8. So it goes from 1 to 3. Okay, that's the first one. And then between 5 and 8. Okay, between 5 and 8. All right. Now, why did I include 8? They included right here. Okay. And that's it, guys. So you see how I had to overlap them? I overlapped them. Okay, just so you'll be able to see. All right. Part C. Part C. It says find the acceleration of particle Q at time t equals 2. Where's particle Q? Well, we're talking about this guy here. The acceleration, that means I got to take the derivative and plug in what? 2. Okay, so part C. All right, so I need my acceleration of particle Q. Okay, so take the derivative of this guy. What's the derivative of this guy? That'll be 2t minus 8. All right, 2t minus 8. Now I got to plug in what? I got to plug in 2. All right, my acceleration of the q particle at 2, and that's going to give me 2 times 2 minus 8. All right, sorry about that. So that should give you, that's 4, take away 8, that's negative 4. Okay, the acceleration of the q particle at 2 is negative 4. All right, is the speed of the particle increasing or decreasing or neither? You see that question? Same type of question in the 2016 question. Same type of question in the 2015 question. Is it increasing or decreasing? Remember, you're talking about particle motion. So what do you have to do? You have to also look at the velocity, okay, of the q particle at 2. That's what you have to do. Find the acceleration. We found is the speed of the particle q increasing or decreasing? So remember, just like in 2016, we have to look at both velocity and acceleration. Velocity and acceleration. So at 2, what happens? So what's the velocity here at 2? So t squared minus 8t plus 15. So t squared, that means 2 squared minus 8 times 2 plus 15. All right, 2 squared is 4 minus 8 times 2 is 16 plus 15. The velocity of q particle, okay, at 2. So let's see here. 4 plus 15 is 19. 19 take away 16 is 3. Okay, the velocity at t equals 2 of the particle q is 3. So you look at that. That's negative and that's positive. So the signs are what? They're different. So how would you answer this question? Okay, it says the particle q is what? Decreasing at t equals 2. Why? Because you could say a of q is negative 4 and v of 2 equals positive 3. And that's it, because these are calculus teachers and they know what this means. Okay? And you can just say the signs are different, period. That's it. You show this work, that's enough for them. Because see, all they want to do is they want to find those points. They want to find that justification. All right? So if you mention the signs are different, you're good. Okay, last one, part D. Find the position of particle Q the first time it changes direction. Okay, so we're talking about particle Q. It changes direction. So what are we talking about? We're talking about its velocity in moving, right? But it says what? Find the position. Okay, let's look at particle Q. What do they give me? They give me velocity. So what do they want? They want position. So what do I have to do? I have to integrate the velocity v of qt dt. Okay, now from where to where? Okay, what's my initial condition? At t equals 0, it starts at 0. And wait a minute, when does it first change direction? So we have to go to the previous information. Well, where are we talking about particle q? We're talking about particle q in part C. Okay, look at actually I'm sorry, part B. All right, remember the velocity here. When does it change direction? Remember, particle q, it's moving. When does it change direction? That means when does it stop? It stops at 3 and at 5 to change directions. Okay, so the first time is at 3. So we're going to integrate from 0 to 3. Fundamental theorem. So now what do? Well, if you do that, you're going to get x of 3 minus x of 0. And what do they want? The first time it changes direction. So what's the first time it changes direction for q? Right here at t equals 3. So now we're going to solve for it. X of 3 equals, take this guy to the left, becomes a positive. That's our initial condition. From 0 to 3 of v of q t dt. Okay, now what do? Well, where do I start? X of 0, they already tell me we start at position of 5. Okay, plus, now we got to take the antiderivative of this guy. Now remember, this is a no calculator problem, so we're going to have to do it by hand. And I think you guys should be able to do it. If they don't give you this crazy integral, okay, dt. All right, so that x of 3. Now just be careful when you're doing this, all right? Take your time. You don't want to be too slow, but you don't want to be reckless, okay? And just talk yourself through it. So 5 plus, okay, so what do? You add 1, okay, divide by 3 minus, you add 1, 8. The T1 becomes T2, divide by the 2. See, so you're just talking yourself through it. The 15 becomes 15T, and then we go from 0 to 3. Okay, remember this guy is separate. All right, and that's what you do. And so let's go ahead and plug it in here. Now we are going to do a little bit of mental math, okay? So let's just write in our stuff here first so we can do some mental math. 8 divided by 2 is 4. 3 squared plus 15 times, 3. So that's the first part. That's the top. Minus, now we got to do the bottom. So, and this is nice because what is that? 0 divided by 3 is 0. 0 divided by this, 0. Good, that's awesome. That's nice. Now just be careful because you gotta check that 0. Just because it says 0 doesn't mean it disappears. Sometimes there's a constant and the students forget that constant. So be careful. Okay, so let's go ahead and do that. You get 3 cubed is 27. 27 divided by 3 is 9. 9 times 4 is 36, so that's minus 36. 15 times 3, that is 45. So when you do this correctly, you should get 23. Okay, so the position of particle Q, the first time it changes direction, is 23. Now, it didn't ask you for any justification, so you can just leave it like that and you're done. All right, guys, so hopefully this helps out, and we'll do some more problems next time.